Hello everyone, I am Dr. Clament Research Assistant Professor working at the Department of Chemistry, SRMIST of Science and Technology, Kottambulur campus. Today I will discuss nanomaterials synthesis, introduction to various synthesis methodologies. Here the most important things to know is the safety protocols, because every synthesis method includes some risk. Therefore, whoever worked in the laboratory have to take the primary safety protocols. The minimum lab PPE have to be used. Say for example, the high protection is very important, and wearing gloves is a prerequisite to start any reactions. Lab coat is a mandatory one before you execute any reactions in the laboratory. Hair care is very important, and then wearing goggles is very important. Therefore, there are certain important lab protocols and safety protocols needs to be followed before you execute any reaction methods. And then we also have to understand the chemical hazard symbols as displayed in the slide. So here what I would like to convey is that the scholars and researchers or master students, whoever work in the laboratory, have to strictly follow the safety protocols and lab rules and terms. Therefore, whenever you try to synthesize any nanostructures, you make sure you safely execute your reactions. Now let us go to the nanomaterials synthesis strategies, which has been broadly classified as bottom-up approach and the top-down approach. So here the interesting thing is, in the bottom-up approach there are two key steps are involved, namely nucleation process and the growth process. Meanwhile, in the top-down approach there are one important steps involved, which is the breaking or cleaving of the molecules, cleaving of the bulk stuff. So in both approaches, the most important requirement is that we have to control the size and shape. In the bottom up approach as well as in the top down approach, controlling the size and shape is very important, because by controlling the size and shape we can tune or regulate the properties. By tuning the properties we can tune the application. So therefore we have to understand the design of synthetic strategy is very important and play a huge role in controlling the size and shape. Therefore, this slide summarizes that by tuning the suitable reaction conditions or by designing the suitable reaction conditions, we can control the size and shape of the nanostructures. Now, let us try to understand what is top-down approach and what is bottom-up approach. Now, through top-down approach, we can end up with nanomaterials. Similarly, through bottom-up approach, we can end up with nanomaterials. Now, we need to understand the top-down approach as well as the bottom-up approach may involve gas-phase reactions, liquid-phase reactions, as well as the solid-phase reactions. Now, with these three kind of phases, we try to understand what is this top-down approach and what is this bottom-up approach. Here, the top-down approach is that segmentation into micro fraction to nanoparticles. For example, the mechanical way, ball milling, mechanical adhesion, mechanical grinding are a suitable example of top-down approach. And the physical method, namely thermal evaporation, thermal pyrolysis, and nanospraying are an excellent example for synthesizing nanomaterial through top-down approaches. The advantage is that it is very low cost and large scale production is possible. Deposition on large substrates is quite feasible in this method and low environmental impact. And the disadvantage is that broad size distribution occurs always in this approach. We cannot prepare a monodispersed nanoparticles or, or we cannot achieve a nanoparticle uh, with the size of a particular nanometer. The broad spectrum of size is a big limitation in the top-down approach. And shape, when it comes to shape, we cannot achieve a uniform shape or monodispersed shape. Here we get a varied particle shapes. And the third one is high product impurities. Comparatively speaking, top-down approach involves impurities. Now let us move to the bottom-up synthesis approach and try to understand. The definition is that assembling ions or molecules into nanoparticles is called bottom-up approach. In the bottom-up approach, there are two interesting strategies are there. One is the chemical strategy and the other one is the biological strategy. In the chemical strategy, this polymerization reduction and oxidation are two most important strategies used to synthesize nanostructures. When it comes to biological approach, scientists or researchers use plant extract or bacteria supported or fungi or algae supported synthetic approaches. Now, the advantages. The most important advantage is that through bottom-up approach, we can synthesize narrow size distribution. Particle shape and composition control is quite possible here, and it is very much suitable for a lab scale. Disadvantage is that it is highly costly, it involves like it's not cost effective method, and large scale production is quite difficult and it requires removal of byproducts. So this slide clearly tells you the example, merits and limitations of the top-down approaches. Similarly, the definition and the strategies of bottom-up approach while highlighting the advantages and limitations. Now let us try to understand bottom-up approach methods, which is the most important in every postgraduate syllabus, because in the postgraduate syllabus this bottom-up approach is one of the main concept to be learned. So here I've placed four important methods by which we can synthesize nanomaterials, namely solvothermal and hydrothermal method. Second one is sol gel method, and third is self-assembly method, and fourth one is electrodeposition method. Does not mean that there are only four methods by which we can synthesize nanomaterial through bottom-up approach. These are the key examples for bottom-up methods. So in this module, I will explain the solvothermal and hydrothermal method for nanostructure synthesis and the sol gel method. Note that both methods or all these methods involves two key processes, namely nucleation and growth, because we need to control the nucleation and growth process so that we can control the size and shape of the nanostructures, which in turn decides the application. Now let us move to the solvothermal and hydrothermal methods. I will clearly explain few important features. Here in this solvothermal or hydrothermal, the reactant concentration and stoichiometry are very important. Say for example, in solvothermal, we need to use a suitable solvent with suitable ratio. And in the hydrothermal method, we need to use water as a solvent. And when we use the water, the stoichiometry of the precursor with respect to water need to be carefully decided. So that is why in this method the reactant concentration and stoichiometry play a huge role. And in this approach we always use autoclave Teflon reactor. The reason is they are very stable and they include locking system. So this autoclave Teflon is very important to synthesize nanomaterials through solvothermal or hydrothermal route. Now, notably, through this method, we can control the product, we can control the nanoparticle phase, we can control the size, we can control the shape, that is morphology, and we can control the pore size, surface area, and composition. The limitation is we can't control the pressure in normal autoclave, while there are a special setup where we can control the pressure. Here you can see that we just take the reaction precursor and we stir it, and when we take the reaction precursor we should make sure we have taken it in a particular stoichiometry, and we'll pour it in the autoclave, we'll pour it in the Teflon tube. After that this Teflon tube will be kept in the autoclave reactor, and which further will be heated in the oven at the desired temperature to get the product. Now, see, this hydrothermal technique has been most admired, I would say the most attempted or used approach. Uh, it, it, it receives attention from scientists and technologists from different disciplines. The term hydrothermal means solely a geological in origin, which was first used by British geologist Roderick in the year 1970, 1792 to 1871 in his time, to describe the action of water at elevated temperature and pressure in bringing about changes in the earth crust leading to the creation of rocks and minerals. Therefore, the hydrothermal synthesis refers to the synthesis by chemical reactions of a substance in a sealed heating solution above the ambient temperature and pressure. Hydrothermal synthesis of single crystal depends on the solubility of minerals in hot water under high pressures. The crystal growth performed in an apparatus consisting of a steel pressure vessel, which is called an autoclave, in which a chemical substance is supplied along with the water. Now we suppose to understand the difference. What is solvothermal and hydrothermal? So here we can see the difference is based on the temperature, pressure, solvent, and then the thermodynamics and kinetics. Yeah, so here where I want to tell you interesting things, that if we want to control any reactions, there are two important aspects to be remembered always. One is the thermodynamics, the other one is the kinetics. After that the stoichiometry, reaction pathway all comes in. However, the thermodynamics and kinetics are inevitable. They are very important. So when we try to understand the thermodynamics and kinetics, we understand the reaction pathway. Then we can execute a reaction in a more perfect way. Say for example, let us take solvothermal and hydrothermal as an example and try to understand the difference. Temperature and pressure. Here in solvothermal, the reactions occurs at elevated temperature and pressure, whereas in hydrothermal, the reactions occur at. Similarly, in hydrothermal method, the reaction occurs at elevated temperature and pressure. Solvent. The solvent used is typically organic solvent. That is why this is called solvothermal method. Such as ethylene glycol means that we can change the solvent easily. We can move from one solvent to another solvent according to the boiling point. But here in hydrothermal, the solvent used is water. So the difference is, here the solvent is organic solvent, here the solvent is water. So that is why this is referred as solvothermal and this is referred as hydrothermal. And here in terms of temperature regulation, it is conducted at relatively low temperatures. The reason is organic solvents have low boiling point. They are low boiling solvents. So we cannot heat the reaction mixture above 500 or 600 or 700 degrees Celsius, at which the organic solvents will cleave and decompose. So here in hydrothermal, it is always conducted at relatively high temperatures. Say for example, like uh, the boiling point of water is 100. So here we can even heat the reaction above 100, no problem. And the thermodynamics kinetics. By controlling the phase, crystallinity, size and morphology, we can control the properties. The thermodynamics and kinetics are the driving forces for the formation of nanostructures that differ as solvent differs. Here in hydrothermal, other reaction conditions precursors needs to be tuned so as to obtain the desirable nanostructures. Now let us understand the advantage of hydrothermal and servothermal methods. Most material can be made soluble in proper solvent by heating and pressuring the system close to its critical point. Materials that may not be obtained via solid state reaction may be preferred through hydrothermal or servothermal synthesis due to high temperature and pressure. Products of intermediate state, metastable state, and specific phase may be easily produced. Easy and precise control of the size, shape distribution, and crystallinity of the final product through adjustment of the temperature such as the reaction temperature, reaction time, solvent type, surfactant type, and the precursor type. Now let us understand the disadvantages of hydrothermal or servothermal synthesis. Here the need of expensive autoclave is the big limitation, and next is the safety. Safety issue during the reaction process always bothers us, and the most important one is third, which is the reaction process. We cannot observe the reaction process as we do in the other cases. That is why the autoclave is often called black box. We don't know what is happening inside. Now the last example for this module is sol gel method. The important feature here is the reactant concentration and stoichiometry. So when we use the sol gel method, this method involves two things: sol and gel, which means solution and gelation. So here the reactant concentration and stoichiometry are very important. And the other key feature is that the gelling agent play a predominant role in this. After adding the gelling agent, there are two reactions takes place uh, at every sol gel method, namely hydrolysis and polycondensation. Now, the important thing that we must understand is that we can control the product nanoparticle phase, even size, even morphology, surface area, and composition. But these control are possible only through the proper design of reaction synthesis methodology. So here let us try to understand the preparation of nanoparticles by sol gel technique. So this is the solution precursor, and after that we take the solution precursor and add into a suitable sol, which means we are going to have a polycondensation reaction, and then the sol will be kept over for a long time to get a gel, and we keep the gel again for a long time so as to age it, and finally we will get the aged cell. See, so in solid gel is a method for producing a solid material from a small molecules. In this chemical procedure, the salt, that is solution, gradually evolves towards the formation of gel, containing both the liquid phase and solid phase. The morphology of which range of the particle to continuous polymer network, ultrafine and uniform ceramic powders can be obtained. These powders of single and multi-component composition can be produced on a nanoparticle shape. Now steps. In sol gel method, hydrolysis is the first step where the precursor molecules react with water, and second is the condensation step. Here the formation of metal oxygen metal bonds occurs, and third one is the gelation where the formation of 3D network occurs, and the fourth one is aging. This is mainly to strengthen the gel structure, and the fifth one is the drying, which removes the solvent molecule, and the last one is the calcination. Through thermal treatment we can obtain the crystalline nanoparticles. Now let us quickly understand the key features. Here, the uniformly mixed raw material in the liquid phase is very important. And carrying out the hydrolysis and polykondensation reaction is very inevitable so as to form a stable and transparent salt system. Colloidal particles slowly aggregate after the aging of the salts to form the gel with a three-dimensional network structure. And the gelling agent, say for example PVA, PEG and PVP, are commonly used, that is polyvinyl alcohol, polyethylene glycol and polyvinyl pyrrolidine. After various processes such as drying and sintering, the materials with a microstructure can be easily prepared. Advantage: starting material are at the molecular level and the final products prepared are homogeneous. Products are relatively higher in purity and we can control the degree of porosity. Easy to prepare in various sizes and convenient to carry out. It enables the synthesis at low temperature. It also allows for the fine control of the product's chemical composition, especially suitable for preparing multi-component materials. It enables small quantities of dopant to be introduced in the gel and end up uniformly dispersed in the final product. And finally, the limitations, that is disadvantage. This method uh, relatively relatively a longer time reaction, and it involves the organic solvent, which are harmful. Summary: bottom up and top down approach are two class of approach to synthesize nanostructures. Here, two things are important. One is there are several methods are available in bottom up and top down. The choice of method is very important, which is which is which is purely based on your reaction design. And the second important thing is the reaction conditions. For every choice of the strategy, the reaction condition is very important. So according to the choice of method and reaction condition, you will be able to produce a better nanostructures. And finally, we have to control the particle size and shape which is very important. That is possible through controlling the nucleation and growth process. So thank you everyone. With this, I wind up this module, which is called synthesis of nanostructures.